It's a good way to start class today. We got 2.3 sets in compound inequalities, specifically disjunction. Now, I don't use the word disjunction very often, though it does appear from time to time in the quizzes, just with the vocabulary stuff, okay? But it's really an or statement, and it seems like we've talked about or statements before, like if one has to be true or the other one has to be true, only one of them has to be true in order to maintain, I guess, truthfulness. That may not make sense now, but I hope it will as we look at more inequalities in this section. All right, so to help us understand this, a set is just a bunch of stuff, you guys. Now, for us, since it's math, usually it includes a bunch of numbers. Now, math people, yeah, they call these things elements. And if I haven't said this before, math people aren't usually as smart as you think they are. That includes myself, and I know I'm giving myself away on this, but I don't mind, because I don't care. But don't tell other math people, because they'll beat me up, by the way. But math, when you start to understand the vocabulary of math, then they tend to change it so that they look more smart than they are. And so, don't get caught up in the hype of all the vocabulary, okay? So I'm going to call these elements a set. I may use that vocabulary as set, but I don't usually use the word elements very often, other than when it asks for it in a specific question. So it's just stuff, okay? So elements are not listed more than once in a set, even if it repeats. So that saves us some work, because math people are also lazy. And you may have seen these before with the different type of number systems. This goes into more number theory than I think anyone ever really wants to talk about, other than math nerds. But this is real numbers, rational numbers, integers, whole numbers, and natural numbers. They're sets of values, okay? Now, every set of values, every number is classifiable within these sets, or irrational numbers. Not that anyone cares. But it's just saying that a number, you know what, I feel like I'm doing too much on this. I'm trying too hard. Let's move on. Sets of things, right? So generally speaking, for you guys, you always deal with sets of things or elements in sets. Like, shoes or shirts or sandals or socks or smocks or suspenders. Now, you could reclassify this in what is called set notation, which I think you see more of in 1010, but we can kind of see it here. Right, all of those things are just things that you wear that start with S. Now, are there more things that you wear that start with S? I don't know, and I don't really care right now, other than to show that this is how this works, okay? Now, another thing that you need to keep in mind with using this set type notation, or even as a list, is you got to use fancy brackets, okay? Now, mine didn't come out really. That one's pretty fancy. I like that one. It's okay. Now, if you're like, dude, I can't use fancy brackets. It's too hard for me. Well, if you want to look at this one here on the left, it's just an S and then a 2 connected to it like that. That's pretty fancy right there, right? Now, for the other one, you just switch it. It's just a 2 and then an S. Bam, fancy brackets. Okay, then you put everything in between your fancy brackets that is part of the list that we're asking for. So, example of a set. Here we go. C is a set of things, and they always use letters for sets. I don't really know why, and I don't really care to know why, which I assume you don't either. But in any case, a set of things you wear that start with S, right? It is possible to have an empty set, which means that you'd still show the fancy brackets right there, but it's possible to use this symbol right here to show that the set is empty, all right? Now, math people are lazy enough, they don't like to use or write whole words all the time. It eventually looks real, I don't know, hieroglyphic type. Like even like this right here, right? So this symbol right here it's telling us that a value is an element of some set, which is usually named by some letter, okay? So like this one, the example, 5 is an element of set G. Right, that's a lot of writing right there. That's pretty rough, and if you had to do it very often, it would stink. So you could write it using just the symbols like this. 5 is an element of G. Bam. It's just part of G. It's a thing. It's stuff in G. Or negative 10 is not an element of set W. So now we're looking at this symbol right here. And so again, this reads, mathematically speaking, negative 10 is not an element of W. You did all of that writing, but with what, 1, 2, 3, 4, 5 different symbols right there, instead of writing all of that out. So it almost goes back to what we talked about in that first lesson, where math, it's supposed to be empowering, right? Like, you're supposed to take control of the numbers, bend them to your will, to look or do things that you want them to do, okay? But it's the same thing with math. They've manipulated it to the point where it may look like a completely different language, okay? So this one, sets are equal if they have the same elements, even if the order is different. So we got, this would be set A right there. Looks like it's burger and fry. Oh, it's too early to be talking about food like this. B, set B, this would be set B is, I guess, salami. Now they did something on this one. Same with this one that they shouldn't have done. Right? Remember, you don't usually list these elements twice if they repeat. Okay, same with the A's right there. Or set C, slamia, I don't know, whatever. Someone made this up. I forget if it was me, actually. It's too long ago. But yeah, they've repeated the A's right there, which is not required for you to do, but it kind of drives home the point on this. And we can see that set B, which has elements S, A, L, A, M, I, is equal to set C, which is the elements S, L, A, M, I, A. So even though it's in a different order for set C, they're still equal. They have the same things inside. But since the order's changed, it doesn't mean that they're not equal. So here we go. Let set A equal these four numbers, 10, 20, 30, 40. And is this true or false? That, again, this reads, you guys, this reads as 15 is an element of A, set A. 15 is an element of set A. Well, I don't see 15 in that set. Those are all multiples of 10. 15 is a multiple of 5. Now, we can't assume either that 50 is part of the set. Because we have closed this with this fancy brackets, it's only got these four numbers in there, okay? But I don't see 15 among the sets, so this one's false. If you said that 15 is an element of this set A, it would be false. Yeah, some people would look at this and be like, well, it's 10 through 40, right? Well, it would look that way, especially at first glance where we're getting used to this. But if it's not listed in the set, then it can't be considered part of the set. So on this one, again, we got the two sets. We got set A and then set B. Oh, ham and cheese and bacon LT. Why not just make it a ham and cheese bacon LT? That's what I would do. But in any case, E, so I can look at both sets, right? I got set A, and I see the E is right there. Right, I'll see if I can highlight this thing. There's E. I don't see E as an element or part, a thing, in set B. So yeah, it's just, as it turns out, just an element of, well, I'll use a different marker on that, A. All right, so again, this would read E, the letter E is an element of set A. Well, why is this important? Because they're going to start giving us these different types of, well, inequalities here in a second, but unions or intersections, okay? Now, union, thank goodness, is represented by U. I wouldn't put it past math people to switch these up just to be jerks or just math nerds, but union is represented with this symbol in interval notation as well. So we need to remember U is that union. It's part of what we're going to see is the or statements of these inequalities. Now, intersection is shown like this, but usually when it intersects on or with an inequality, we don't usually use the symbol. But we can with these sets, right? So we got these two sets, A and B. And this first one is showing that A, this would be A or B, right? So this is asking for any elements that are part of A or that are part of B. It's frozen on me. One second. you'd be listing any elements that are part of A or B, right? Like 1, while it's not a part of set B, it is part of set A. So again, it's only one or the other. So yeah, we got 1, 3, 4, 5. 7 repeated, but again, you don't need to show it more than once. In fact, I think if you do it on the homework, it's going to mark it incorrect. Then we got 8, 9, 11, which repeats, and then 15, 19, and 20, which are all part of this set, which shows that it's either going to be an element of A or B. Now, the next one is the intersection. So it needs to be and. It's an and statement, so it needs to be part of both sets here. So it needs to be part of set A and B. Now this, of course, should be, it's usually a much smaller set, but like it shows here at the bottom, right, 7 is an element of A and B, but then 11 is as well, right? 11 was part of both. Sometimes I miss some of those. I don't see any others that are part of both. Okay, so it has to be part of both sets when we look at this type of symbol, which is asking again for the intersection. It has to be part of both. Now, what we're getting to on this is eventually they're going to start showing us two separate inequalities, and the only answers for this and stuff, which is part of the next section. The only answers that are true for and statements need to be true for both. Okay, so even though the line may stretch on these ones for these and statements, right? Like you may see purple line like this, and then green line like this. We're only looking for where the elements or the numbers that would make it true for both. Okay, so I'm jumping gun on this, which is only the values in between these. Okay, we'll talk more about that in a second. On the other hand, for or statements, let's say that you had a line like this one. It could be closed circle, and this one goes to the left, and maybe this one open circle going to the right. Okay. So all the numbers under the red line and in the red circle even would make those inequalities true, while the numbers in this underneath this orange line would make it also true. So in fact, only these ones in between would make those inequalities false. So again, we've only been dealing with, as of right now, just like one of these, right? So you wouldn't see this orange line here. It's like, yeah, you can write the interval notation for the red, but as soon as we add a second line to that, we need to be able to write the inequality, or the interval notation, rather, for one that's right there as well. All right, so we have this one now. We got set A and set B. You know what, you guys take a minute and see if you can list the elements of, again, this would be A or B right here, and this one is A and B. So just take a minute, see if you can do it, then we'll go over it, all right? 1 minute, go. Yeah, this first one, A, and that's a U for union, so it's A or B, and it just needs to be one or the other. And by the way, the homework doesn't really care if you guys list these from least to greatest. I'm going to, just because, I don't know, it makes me feel good inside, all right? But you don't have to. So I would say, well, I'd be looking for the lowest number right there is, bam, 31. And then we got 32. Now, we got 32 twice, but again, you do not and you should not list it twice. Just the one time is fine. And then I got this 34 right there. And then again, we got 45 twice in both sets. Now 47 in both sets. And yeah, I'm going to run out of space, but I'll figure it out. Next up, 48. There we go. And then 51. And finally 60. Now, if this is what you wrote down, it down, just exactly the way that I have it written, and if it was like a test that we usually used to do a test by hand, then I'd have to take a point off. And hopefully you guys remember that it's because it's missing fancy brackets. So there we go. Pretty fancy brackets right there, you guys. So yeah, whenever you're doing it by hand, don't forget to put your fancy brackets in there. They're so pretty. So yeah, fancy brackets. I'll start this next one with fancy brackets. But let's take away the red there so we can see what the heck is going on. Oh, it won't let me. Dang it. That's all right. I'll highlight them. So again, we're looking for any values that are part of both sets. It's part of A and B. So I'm looking at those 32s right there, so let's go and put those in. And then just, scanning it, there's a 45, so we'll put that in the list. And yeah, I found one more, 47s. And I don't see any others that repeat, and yeah, I've been known to miss a few here and there, but I don't see any. So if you guys see it, then just let me know. But as far as I can see, the set A and B would include just these three values, 32, 45, and 47. But again, don't forget your fancy brackets. Now, if on the homework they were to give you, like let's say that there were no elements that were shared by A and B, then you just write D and E in there. I know I showed you guys the empty set stuff, but on the homework it's just going to want you to write D and E. All right, so this brings us to the inequalities like we've been talking about, all right? Now, it's good if we can just focus on one of these at a time, and we don't get overwhelmed so quickly by how large these things can look. Okay, so like if you need to do one of them, take a break and then come back, that's good. But if you can do it at one time, who's to say that's better or not? But in any case, we're going to start with this x is less than 5. And there's not really much I can do with that, right? I just know x is less than 5, okay? So I can graph that. I can put that in here on the graph. I'll put 0 over here, 1, 2, 3, 4, 5. So I'll graph it in red so it kind of matches, right? Then we'll do interval notation still, but at 5, since it's not equal to 5, it means that 5 would make it a false statement. So I make that an open circle. Now again, for me, I say that's not eating the x, which means that this line would go to the left, to a negative infinity, right? Now before we do interval notation, let's see what this looks like with the other inequality, which shows x is greater than or equal to 12. So on my graph, my number line, I got 6, 7, 8, 9, 10. That's a bad 10. Let me try it. There we go. And 11 and 12. So I will mark 12 out there so we can see it. And it is equal to 12. 12 would make that a true inequality. So I'm going to close that circle in. Excuse me. And since it is eating the x, it goes to the right here. Okay. So this is the graph, which it did ask for. And now it's time to do the interval notation. So I'm going to do both parts in different colors because remember, since it's an or statement, both number lines, let me rephrase that. The red and the purple parts of the number lines would make one or the other true, right? And that means that these numbers in between would make both of them false. All these numbers in between would make both of them false, which includes 5 because it's an open circle. So just using interval notation with these graphs, the red one goes as far to the left as negative infinity. There we go, that's nice and curved now. And where does this red line stop to the right? Bam, 5. Now again, is 5 included? It is not because it's an open circle. So I can just put a regular parentheses there. I gotta make those a little bit more emphasized. I feel better about that. So then it skips to 12, right? So 12, with that purple number line, it's included because it's a closed circle, so I got a square bracket right there. And then how far to the right does this number line go? It goes to positive infinity. And just like we talked about before, infinities are never actually included in the solution set, so I need a regular parentheses around that infinity side. Now, in between this, it's an or statement, which means it's a union. Okay, so we're uniting both of these. The red and the purple intervals would give us true statements, one or the other, or, it could be both, but that doesn't matter, okay? So there's our interval notation, but the U part of this U in between is, you have to put that in there with interval notation, okay? Like, don't write or. I know it means or, but if you write or in the homework, it's going to mark it incorrect. Now, that example did not require any solving of inequalities because we just want you to see that once you get the x by itself and the coefficient of x is 1 with these inequalities, just graph it. Okay? So this is kind of like double the pleasure, double the fun. some kind of gum commercial back in the day, but as much as you guys like solving these inequalities, you get to do it twice now. So much fun, man. And yeah, we're going to solve it, we're going to graph it, we're going to give the interval notation for it. Okay, so 3 different parts, essentially 3 different answers for it. Yeah, and we have to be careful with just the straight inequality on this, because the and ones are a little bit different. And these ones can change as well, by the way. But we'll see. So I'm going to start with this one on the left. Okay, this one right here. Again, I did purposely put that other one out of the picture so that I'm just focusing on this one, right? And yeah, I'm just going to apply my principles of inequality. You guys like to keep the inequality sign with us, right? So that's going to zero out the 3 there, drop the 6x. Negative 15 minus 3 is negative 18. And I'm dividing by a positive 6. So even though the 18 is negative, it's dividing by a positive, which is going to keep that inequality. It's not going to flip it, I should say. Now that solves that first one. X is less than negative 3. That's good. Let's go to the next one, though. This one right here. Okay, so again, I put that one out to the side. I don't need to look at it or think about it right now. Let's just figure this one out. So again, more principles of equality. Let's zero out that 7 to isolate my x's. So yeah, that drops the 5x. We'll zero that out. So now 5x is greater than or equal to 20. That's going to turn out very nice. Divide both sides by a positive, which is going to make x now, not equal. There we go. X is greater than or equal to 4. So this produces our inequalities, both of them. Sorry about that, you guys. So this is both inequalities, the red and the green one right here, would constitute the entire answer for this, except for one final thing, and this is, again, only for or statements. Just write the word or between it, okay? Now, it is possible in the future some teachers be like, hey, you don't have to write the word or, just put the U symbol between it. For the inequalities, I like to see the or statement, right? It's almost like we're just dropping down this or right here. So that's the inequality portion of this problem, but it did say to graph and write the answers in interval notation. So here we go. Let's do the graph, because again, I use the graph myself, not that you have to, in order to write the interval notation. Okay. So again, I'm going to put 0 in the middle, and I know negative 3 is just 3 to the left here. Now I'm just going to graph that for now. We'll come back to the 4 here in a second. But it's x is less than negative 3, so it's an open circle because it's not equal to negative 3. Again, this open circle communicates that negative 3 would not make that original inequality true. It's not true for either one of these, the red or the green one. Okay. Now it's not eating the x, so for me that line's going to go to the left. And that completes the red line on the graph here. So to the right we got 4, right? And this one we'll do in green. So at 4, this one is equal to the 4 though, so this is not just a circle, it's a closed-in circle like this. And this one, its x is greater than or equal to 4, so it's eating the x, which means this line goes to the right. And this would complete the graph. Now again, we're at the point where we just need to write the interval notation. So again, I'm going to write these with the colors that we have, right? So on the red, on the right, I'm going to use red. And the red line goes as far to the left as negative infinity. And again, it's not included, which is why we got that parentheses right there. And going to the right, it stops at negative 3. Now, negative 3 is an open circle, so it's just a regular parentheses as well. Now, in the last problem, I didn't write the U in there till later, but right now I can see that it's a union between the green one and this red one that we have. So again, this just indicates that all the values in between negative 3 and 4 here, and including negative 3, would not make either one of those true. So now, starting with the green one, to the left we get 4, which is included, so it's got a square bracket there. And this green line goes as far to the right as infinity, which is pretty big. So 3 parts here, right? We got the original inequality right here. Then we did the graph, and then I used the graph to write the interval notation. So as it turns out, nothing's really changed except for the size of the problems, right? You're only going to ever narrow it down to this. You're going to graph this stuff, and then you're going to write your integral notation. Now, we do have to be careful, though, right? Because if for some reason these two crossed each other, it creates a unique scenario, which I assume we're going to see here in a moment. So here we go. More inequalities to solve. And we love it so much. This one just has some distribution as part of it, right? So again, I just focus on one at a time. So let's focus on this one on the left. I'll try to keep my colors the same. So I'll do this one in red. I'm going to zero out that -2 by adding 2 to both sides. And yeah, that makes that right side very pretty. That zeroes out. Drop my 5x, -5x rather. You guys like that sign with it? 23 plus 2 is 25. Now right here I'm dividing both sides by -5, right? So I did divide both sides by a negative, which means I need to flip that inequality. Now x is less than or equal to -5. And again, that completes that portion of the inequality, except we need to go to the next side, right? The 4 parentheses, yeah, we're going to have to distribute that 4. So yeah, I'll do this one in green, the whole thing in green this time. So distributing that 4 times x is, yeah, 4x, and then 4 times -4 is -16. This is all less than -8. So I'll zero out that 16 by adding 16 to both sides, like this. So that zeroes that out, drop my 4x, now is less than, well, just +8. Divide both sides by the coefficient to make that a 1. And we divide by a positive, so it stays less than just 2 right there. So again, bringing this back out, let's look at both because we completed that one on the right. And again, just to finish this off for me, I would put the or statement in between the two, which would then be the answer as inequality. So now let's look at the graph because this one is going to create a unique scenario as well. So yeah, right in the middle, put 0, and to the left, 1, 2, 3, 4, 5 is -5 right there. So I'm just graphing the red part of this. And x is equal to -5. It could be equal to -5. That would make it a true statement. So I'm going to color in that circle. It's not eating the x, which means the line goes to the left. So that completes the graph for the red. Now the green, though, it's 2 to the right of 0. That's +2. This one's an open circle because it's not equal to 2. And then this one also, since it's not eating the x, it goes also to the left. Now hopefully you guys are thinking, well, that's kind of weird. We didn't expect that. We haven't seen it. Well, yeah, we haven't done very many problems either. Okay, so on this one, like if we said, you know what, the interval for the red, you would have said it goes to -infinity and then it stops at -5, and you'd be right. And then that would have a square bracket right there. But the green one also goes to -infinity, and then it stops at 2, though, not included. So, I mean, how do we combine these two? Because it only has to be one or the other, which means that, I'll use a different color on this part, everything to the left of, and including -5, is also true not only for the red line, but also for the green one as well. Okay, which means that the purple line now that I've drawn is included in the green interval. Okay, now it was included in the red one, but it doesn't just stop at that -5. It continues on to the green circle because this green portion of the line would also have made one or the other true. So it creates a unique interval in relationship to this or statement that we started with, which also means that the final answer for the inequalities, actually, we didn't need any of this stuff, right? We just needed to say that x is less than 2 would make one or the other true. Okay, because again, in green there, it includes all the answers to the red one here. Okay, so yeah, we don't need this interval here. Parts, because you bring up a really good question here, okay? So the inequality itself is just x is less than 2. We don't need the or statement because it's redundant to say that x is also less than or equal to 5. So that's the inequality portion of it. That means also on the graph, it would be redundant to put 2 lines on there. So all you're going to do is you're going to find 2, right? So there's 0 and then 2. And you'd put an open circle at 2. Line goes to the left. to infinity. And then the interval, I know it's right there, but I'm going to rewrite it. So yeah, this green line goes all the way to negative infinity, stopping at 2, which is not included. So that would be all three parts. Down here, I'll box them in and make that. I don't know if that's any more pretty, but it looks good. So again, the inequalities, they're not really going to change in terms of difficulty, I would think. It just means that, we're going to make them bigger, right? So again, focus on one at a time. And I just always focus on the left because I'm used to scanning from left to right. So again, we'll zero out this plus 7, right? So it's minus 7 from both sides there. And drop the negative 6x. That zeroes out the 7 just like we wanted it to. 25 minus 7 is, 18. We've seen this already. This may create a unique scenario, but dividing both sides by negative 6, right? So I divided both sides by negative. I must flip the inequality now. So x now is less than or equal to negative 3. 18 divided by negative 6. So that completes that first inequality, but we have the second one. So yeah, we got this one. 3x minus 4 is greater than 2x plus 10. And yeah, I'm going to put my x's on the left, you guys. And not only because, you guys like it, which is a good reason to do it, but it's because it's going to make the coefficient of x a positive, so I don't have to worry about flipping the inequality. That means that I can get rid of this negative 4. I'm going to add 4 to both sides. And yeah, just for the sake of time, I'm going to do both parts at once. So I'm going to zero out that 2x right now, okay? So that does zero out the negative 4. It does zero out the 2x. So 3x minus 2x, that's 1x. And we didn't do anything. We just used principles of equality for addition and subtraction. So it does not affect the inequality. 10 plus 4 is 14. Now you could divide both sides by 1, but I'm just going to make it a phantom 1 right there. And, that's, I almost boxed that in. That is that inequality, that part of the inequality. Now again, I'm going to put the or statement right now because I have a tendency to forget it. And then we'll see if we need it in the end, okay? And like I said, I like to see the number line before I do the interval, so let's go ahead and start with that. So we got, I'll start at negative 3. Now for me, by the way, it's just, you don't have to put all the lines in between. I just got negative 0, negative 3. I like to see where the numbers are in relationship to 0, though. So, if you wanted to put 14 over here, and I know those aren't proportionally apart from 0, but I assume you don't care because I don't. But x is less than or equal to negative 3. So at negative 3, we got a closed circle there. It's not eating the x, so we know the line goes to the right. I'm sorry, the left. Man, I need more sleep. So the next one, the green, x is greater than 14. Got an open circle at 14. It is eating the x, so the line goes to the right. Again, this indicates that all the values between would make not just one, but both false. So now that I got the graph, I'm ready for interval notation. The red line goes as far to the left as negative infinity. It stops to the right at negative 3, which is included. So again, got a square bracket right there. Make sure your square bracket's not pointed the other way because it would then, it just seems like it would communicate the wrong thing, like everything else to the right is included. It's just not the right notation, okay? Now this is an or statement, so I'm going to unite it with the green, which starts at 14. Now 14 is not included because it's an open circle, so I got a parentheses there. And this goes as far to the right as infinity, which of course is never included. So there we go. We got the inequality, we got the graph, and we got the interval notation. Bam. Solving these with fractions, I know you guys like them, I can see in the comments, but solving these with fractions is just like solving equations with fractions. It's just you have to remember, if you ever multiply or divide both sides by a negative, you got to flip the inequality. So yeah, I'm grateful we haven't seen any fractions yet myself, but I'm also surprised. Usually the answers will end up being fractions. There will be problems like this on the homework where it just says solve and graph, which means all we need is the inequality and the graph. Now I'm going to do interval notation just almost for practice. Yeah, don't hold that against me. I'm not going to, but you could if you wanted to. So yeah, same idea with these ones, just focus on one at a time. And I hope the color coding kind of helps with this, but yeah, I'm going to put my x's on the left and the numbers on the right, specifically to keep the coefficient positive, because I can see I got more x's on the left than I do on the right, which sometimes isn't so obvious, but it is right here. So yeah, I'll do this in one step just to save us a little bit of time and space there. I need to get rid of that positive 5, so I'm going to zero it out by subtracting 5, again from both sides to maintain the equality part of this, which does zero out the 5. I also need to zero out the 6x. So subtract 6x from both sides, and that zeroes that part out. So 12x's minus 6x's, yeah, it's 6x's. And again, we haven't used any principles of equality that would change the inequality part of that. So negative 7 minus 5 is negative 12. Now again, I want to reiterate this. We're dividing both sides by the positive, right? Even though the 12 is negative, it doesn't affect the inequality because we divided both sides by a positive. This is x is greater than negative 2. So that completes that inequality, but let's look at the next one. I'll keep it in green. Now this one I'm gonna purposefully put the x's on the right. Not that you have to. You know what? The class has spoken. All one of you or two, but that's the way it's gonna go. Okay, so x is on the left still, numbers on the right because it doesn't matter. And again, just looking at this one, the negative 20, I got to zero that out. So add 20 rather. To both sides, it does zero that out. 7 plus 20, 27. And the 14x, I got to get rid of that, zero that out. Right, so subtract 14x from both sides. 5x's minus 14x's would be negative 9x's. So right now, I have negative 9x is greater than 27. But as soon as I divide both sides by negative 9, which is what I'm doing, to make that coefficient 1x, I do need to flip the inequality. X is now less than negative 3. Now that flipped that inequality. Let's look at the other one because you should get focused enough where it's like I forgot about what that other one was. Now, as of right now, I'm going to put the or statement in between, even though it may change, right? And I see I've got one inequality that eats the x, one inequality that doesn't. So we should end up with a pretty normal situation, even though we're not. So here comes the graph, right? So I got 0, and you know what, I should probably put 0 farther to the right over here. And then negative 2 right there, and then negative 3. I just spaced it apart on purpose so we can tell the difference between these. And negative 2, oh, maybe this will work. Negative 2, we got an open circle because it's not equal to negative 2, but it is greater, x is greater. It does eat the x, so this red line goes to the right. With the negative 3, right, another open circle, it's not eating the x, so it does go to the left. So again, this is a pretty normal situation actually. And the two intervals, I always start with the one farthest to the left, even though in the past it's been the red ones that are on the left. But again, the way this one worked out with dividing by that negative, it flipped it. So I'm going to start with the green, which goes as far to the left as negative infinity. It stops at negative 3. Open circle means we got that regular parentheses right there. And we're going to unite it with the red part, starting at negative 2. So we got a parentheses there because it's an open circle. This goes infinitely to the right, which is not included either. So even though it didn't ask for the interval notation, I put it up there. And again, there will be problems on the homework that do not require the interval notation, if I remember right. Yeah, let's address that. So even though I did the red one first, I may have wrapped it out of order because I forget now. But so let's look at the interval, okay, that you're talking about. So let's say that we wrote the interval like this. All right, and we the or statement with the negative infinity to negative 3. Right, and this doesn't make sense because from a mathematical perspective, I'm not saying it doesn't make sense to you. The homework would mark that incorrect because it has to be in order like it is on the number line. Okay, you have to show everything on the left first, even if it was the second inequality. So you have to show the green here first and then the red. because again, we're scanning that number line for the interval as well. So you have to start from the left and then move your way to the right. Whereas this one shows, if you started at -2 and went to infinity, that should be complete. But then to say it's OR with numbers that are less than these two on the right side, again, it would be like using a number line, but doing the order opposite, right? It'd be like showing a number line, I guess, kind of like this. And this does happen from time to time where students, it's like, well, negatives over here and positives over here. I mean, the communication's good. It's just math as a universal language, which it's not, would say that we can't have that stuff. So while I don't, personally care, the computer does, and so do other math people. Wish there was more fractions though. So, but not yet. All right. So again, just solving this like we would with a regular inequality. I'm going to distribute the 5 first. So 5 times x is 5x. 5 times -1 is -5. Now we got this -5 is less than 10. And yeah, I can combine some like terms here with the -5 and -5. That's going to be -10. So now we've got 5x minus 10 is less than 10. Now I'll get rid of that -10 there. I'll zero it out by adding 10 to both sides. And yeah, I'm going a little fast here. I apologize. It's just, I got to get through that next section as well. So divide both sides by 5 and x is less than 4. Kind of emphasize that. X is less than 4. Okay. So that's our first inequality right here. Try to keep the color the same. This next one, no distribution, no combining like terms, but just like you guys like it, we'll put the x's on the left and then the numbers on the right. So again, we'll do it in one step here. I'll zero out that +6 there by subtracting 6 from both sides. That does zero it out. 14 minus 6 is 8. And then add 6x to both sides to zero that -6x out. Zeroed out. Bam. 2x plus 6x is 8x. And now I have 8x is greater than 8. Divide both sides by +8, which means that inequality stays the same. X is just greater than 1 there. All right. So that was the second one. This is an OR statement still. So let's look. And yeah, we'll write the OR statement between this, even though it may require some changing. Some of you guys notice something funny going on here, and you're going to see it in the graph as well. All right. So I'm going to put 0 here, 1, 2, 3, 4, 1 and 4, right? So I'm going to start with the red just because I always start with my left. I got an open circle at 4 because it's not equal to 4. It's not eating the x either, so this line goes to the left. Now the green one, its x is greater than 1, so at 1, another open circle, and this line also goes, well, it doesn't also, but it goes to the right. Now, unique, right? And I think I talked about this in a little bit before, but we'd have to ask ourselves, right? Because I always look at the graph in order to make the interval notation, and I'd say, well, how far to the left does this line go? It goes all the way to -infinity with that red line, right? Now I would trace this red line going to the right, and I would stop at 1, except I wouldn't stop at 1 because the red line itself continues to go to the right. Remember, it's only got to be one or the other. So as of right now, I can follow the red line all the way to 4, and then if I want to jump ship and jump on the green one, I can, and then I can actually go all the way to the right to positive infinity, you guys. Oh, that didn't, let me try that again. Positive infinity. There we go. And it's not included. That's the interval right there. Now that changes the inequality as well. We don't want to write it like this. Okay. We have to show that it's all real numbers, and well, I would say that it's all real numbers. I like to use the symbol though because I'm a math guy and I don't like to write it that much. That's the symbol for all real numbers. I believe on the homework it just gives you an option, all real numbers, or you could type DNE. Not on this one, but for empty sets, right? But this is the interval notation. X is all real numbers, and then the graph, again, the graph wouldn't look like this on the homework. You guys would see the plane graph like this, once again, you'd have to show that the line goes from end to end. So you wouldn't even choose the circle option to put these on there. Okay, you're just going to choose the line option, then just span it from end to end. Yeah, the one in green right here, it's included in the red. And remember, it only has to be included in one or the other. So even though it's not included in green, it's included in red. So we don't worry about that being an open circle because it falls under the red line. And then same with the 4. The 4 was an open circle, which means it doesn't make the red inequality true, but 4 would make the green inequality true because I didn't really put it under the line, but it falls under that span, that interval. So yeah, even though the red line stopped at 4, the green line not only includes 4, but it continues onward to the right.